So this sounds fancy, reducing unwanted energy transfer. It's not. Basically, what I mean when I say this and what we talked about in class is insulation. How do you make sure that the heat you want inside the house stays inside the house? How do you make sure that the heat outside the house stays outside the house, okay? Or cold, or whatever else you're interested in. All right, usually we talk about this in terms of houses. That's what I'll be talking about as well. But of course, there are other things. I don't know, like a thermos, right? Think about what parts of a thermos might help prevent transfer of heat via different things. I would highly recommend, if you haven't already, if you're not comfortable with the idea of the 3 ways that heat can be transferred, that you watch that video before watching this one. All right. So I'm going to talk about how do you prevent unwanted energy transfer, and by this I mean heat energy transfer within a house. All right. Now, if you were to slice open the wall of a house, usually what you would find is that there is an airspace in. All right. So let's say that this is inside the house where it's nice and cozy and warm, and this is outside where it's blazing cold. All right, there's snow and everything, and brr. And so the idea is you don't want the energy, the heat inside the house that you've paid money for to heat it up, going outside the house. All right, so this is your wall. Now, the first thing you'll notice, that, like I said, is there's an airspace inside. Okay, and the point of the airspace is so that this is not one solid block of cement or wood or whatever it is you're building things out of. All right. And so, because if it were one big block, then what you would do is you would get a lot of heat transfer via conduction. Right? Remember that conduction is the transfer of heats in solids. And so the idea is that if this inside here where it's warm, right, the particles would be vibrating a bunch, and then that vibration would just get carried right to the outside, so you'd lose heat that way. So the airspace prevents conduction. Now, the problem with that, though, is, if you've watched the other video, is that if you have a bunch of air, it's not just about conduction, right? The other way that heat can be lost is convection currents. And so the idea is that if this part of the wall is warm, then that means that all the air particles here are getting excited and they're speeding up because they're getting more kinetic energy, and then they're going to move away from that heat source because they're going to expand and become less dense, and they're going to move away from it. And then you're going to get a convection current going around and around and around inside the wall. Well, that's a problem. So what do they do instead? They put in an insulation. Sorry for my terrible drawing. And this is called glass wool fiber. And glass wool fiber it's got, I'm sure you've seen this before. It's yellow or pink often, and it looks kind of like a really uncomfortable mattress. Please don't try to make it as a mattress. Little pieces of glass will fall off and it'll be very uncomfortable and scratch you up. But anyway, so glass wool fiber basically has little tiny pockets in it. And the little tiny pockets of air mean that it's still not a total solid, so you're not going to get conduction. All right, but the small pockets are so small that the air that's trapped inside can't really get into a good convection current. So the small pockets of air prevent convection currents. Now, in addition to these two, right, if you think about the 3 ways that heat is transferred, the other thing you have to worry about is radiation. And radiation can be reflected by having shiny surfaces. So again, you'll see this as well. So pretend that this is shiny. Okay, so this could be, for example, foil, or some other reflective thing. And it can often line both sides here. And so the idea is that if you have, again, anything that has heat produces infrared waves. And so the idea is that the infrared waves, if they're coming from here, they're going to hit this and then bounce off. So they're not going to go outside. And the reason that you want it on both sides is so that in case when it's hot outside, right? So here I have it, for example, in the cold, but in the summer, you would want the same thing. The heat coming in here, you want it to be able to bounce back off so that your inside of your house stays nice and cool. So the foil lining the wall prevents infrared waves, or it doesn't prevent them, I should say. It reflects them. It reflects the infrared waves so that the heat doesn't escape or doesn't get in, depending on what you want. All right, so that's a way that we deal with trying to reduce unwanted energy transfer in terms of heat. The only other thing that you probably should know is about windows. All right, so windows, of course. So here's the thing, right? You want to prevent conduction and convection and radiation if you want to make sure that you're reducing unwanted heat or energy transfer. The problem is, of course, with windows is you can't put shiny stuff on it, right? That doesn't work. Otherwise, it's not a very effective window. It works, it's just not a good window then. And so the idea is that instead we focus on preventing conduction and convection, and we do that by, so for example, again, this is a window here, and these are glass panes. So these are glass panes, and there's two of them. So again, you have an airspace in here. All right, and so again, it's not fully solid, so you're reducing the likelihood of conduction. And then having the airspace means that you could get convection. So instead, what they do is they put in a low pressure gas, and it doesn't stop it entirely. But if you have low pressure, then that's because there's fewer particles around. Fewer particles means that you're less likely to get convection currents. And so this is a window. This is called double glazing. That's the term for this when you have these two panes. And if you go up north to some Scandinavian countries where it gets really, really cold for most of the year, you can even get something called triple glazing, and it's literally 3 panes of glass because the double isn't quite enough. All right, so those are different ways that we prevent unwanted heat energy transfer in our homes.